This is Mr. Beck Does Your Homework. This is AP Physics Homework 2.6, questions number 7 and 8. Looks really complicated. It says, you are standing at the top of a cliff that has a stair-step configuration. There is a vertical drop of 4 meters at your feet, then a horizontal shelf of 7 meters, then another drop of 6 meters to the bottom of the canyon, which has a horizontal floor. You kick a 0.29 kilogram rock, giving it an initial horizontal velocity that barely clears the shelf below. Barely clears the shelf below. What initial horizontal velocity will be required to barely clear the edge of the shelf below you? The acceleration of gravity is 9.8. So for this first part of the problem, I'm just interested in right here, this portion of the flight. So I've got an initial velocity, so I've got an x world, I've got a y world, and let's see what I know. For this part, I'm going to travel down 4 meters, so my y displacement is going to be down 4 meters. The horizontal shelf of 7 meters, it's going to fall down 4 and over 7. It's going to get right to that point. So I can say that my x displacement is going to be positive 7 meters. I also know that my acceleration is gravity is negative 9.8 meters per second squared. So it falls that, it's got an acceleration of that, and I've got an initial horizontal velocity, but I don't know what it is. That's what I'm looking for. And I don't know the time. Here I know that my initial velocity in the y direction is 0 because this is a horizontal projectile. If I had the time and I have the distance, I could get myself a velocity. So what I'm going to have to do is figure out time from this. Now, conveniently, if you've been paying attention, you see that the equation that y equals v0t plus 1/2 gt squared. If the initial velocity is 0, this equation gets rearranged. So I multiply by 2 and divide by g. So I get 2y over g, that would be t squared, so square root it, and that's going to give me my time. So my time is going to be the square root of twice y, which is -4, so that's twice -4, which will give me -8, over -9.8. That's going to give me a time. Now, what do I do with that time to figure out what my velocity is? Well, I know it moves 7 meters in that amount of time, so my velocity is just my displacement over my time. So it's going to be my displacement of 7 meters divided by the time that I got down here. This time goes right in here. And that will give me a velocity that it is traveling when it leaves. So there is my velocity in the x world. That will be the answer to question number 7. Question number 8 says, how far from the bottom of the second cliff will the projectile land? Well, this could be a really complicated problem if you tried to start here. So what I'm going to do is I am going to just imagine that I know my initial x world velocity now, but I'm going to turn this into a single problem where I'm just going with that velocity and I fall 10 meters. How far am I going to go? Total 7 plus delta x. Okay, so what's this total distance that I travel? It's going to make this problem a lot easier. So what I'm going to do over here is I still have x world, y world. And what I know still is that in my x world, now I've got a velocity that I got from before. I know that my x displacement is what I'm looking for. I know that my time I also don't know yet. In my y world, I know that my initial velocity at the very tippity top is going to be 0. I know that my acceleration is going to be g is going to be negative 9.8 meters per second squared. I know that my displacement when I fall from the tippy top all the way to the bottom is going to be 4 plus 6. So that's going to be negative 10 meters. And then I can figure out my time from over here. So again, I'm going to use this radical 2y over g. So my time is going to be the square root of twice my y, so that's twice negative 10, divided by my gravity of negative 9.8. So if I take this times this divided by this, that'll give me a positive. That will give me a new time that it takes to fall the whole distance. So now that I know my velocity and my time, now in the x world, I can say that my displacement equals my velocity times my time. So my displacement equals this velocity that I figured out in part 1 times my time, which I just figured out in part 2. So my time goes in here, my initial velocity goes in here, and I will get myself a displacement. But don't plug that into Utexis, because that is your, in my case, 7 meters plus delta x. So that equals 7 meters plus my delta x. If I want only delta x, then I've got to take whatever that was minus 7 meters to get just the change. And that's what I'm looking for. So be careful not to plug in this whole distance, because that's this whole distance. You want to subtract the 7 just to get this little delta.